So for 7-2, it's very similar to our 7-1, and we're finding this confidence interval, right? So we're talking margin of error, confidence interval, and what's the middle? Our point estimate, right? So it's going to be a mean this time instead of a proportion or a percent. So this time we're looking at that same idea with our means. So our point estimate is our mean, okay? And our confidence interval will be between those two numbers. Like basically we're saying here's the middle based on our sample, but we're going to have some error. So we'll say we're confident you're between these two instead of saying you're right at this. Because it's not very good to say, all right, well, I got a sample of all the women's weights, and most women weigh 150 pounds, period. 150 pounds. That's just the number. Without saying we have some error in that. We took a sample, and so we calculate that error and say, oh, okay, well, maybe it's 149 to 151 or whatever we figure out from our sample. So that's what we're going with. But this time we can't use the normal calculator and the Z because a mean is a different kind of distribution. So it's a T distribution, not a normal distribution. So we have to use something called the T two-tailed, see the little two-tailed symbol, to find that margin of error. So this is our sample standard deviation. So sometimes that's S or sometimes it's SX, okay? And this is the sample standard deviation. So I'm writing that down because this one is the population standard deviation. It's a big deal on this one, standard deviation. Okay, so we talk about this being not known or known. Okay, so what does this symbol mean? It means the standard deviation of the population. How often do you have the full population standard deviation? Like hardly ever. So a known, to know this, is really rare. Okay, this is a rare situation. In that case, we use a Z distribution. If we're here, we use a T distribution. So that gets a little tricky. Okay, almost 99.999% of the time you're using a T, but a small percentage we use a Z. So when we go to set up a confidence interval, let's see, this symbol on yours, it should look normal on yours, but it's just this two-tailed symbol. Um, the degrees of freedom is new. Okay, so it has it up here too. Degrees of freedom is just how many numbers in your sample minus one. And we minus one because it helps, I guess, with, I don't remember if it's like exactly error and what the definition exactly was on it, but it helps us be more accurate with our T distribution if we do one less than our sample. Okay, I could Google the actual definition, but I just care that you know degrees of freedom is 1 minus your sample size. So here is, this is the formula we're going to use for our margin of error. So that's the formula we'll use, or we can use StatCrunch, which I'll show you, right? We could use StatCrunch, get our lower value and our upper value on our confidence interval, subtract them, and divide by 2 and get our margin of error that way. We don't have to use the formula, but we can. So this has to do with the next section. So we're just going to kind of ignore that. So here's what that T distribution looks like. It actually changes with the number of sample sizes you have. So the more sample sizes you have, the closer you're going to get to that normal, kind of more curved up. So it shows the normal in green, and then like the less, it's more spread out a little bit different. That's kind of what a T distribution looks like. It's a little more, usually a little more, it's still like a bell-ish shape, but a little more tall, skinny. Yeah, that's a better word, skinny. All right, so to find that value, we call it our critical value. That's going to be our T two-tail divided by 2, right? We have to go to StatCrunch and use the T calculator. So in order to use that formula for my margin of error, I'm going to have to find this value, this critical value of a T. That is just, on a normal calculator, it's your Z, right? It's like I have a probability, I put in like 0.95, and these two numbers, I'm between these two numbers to be 95%, right? It's the same for your T, but the number's a little bit different because it's based off of the number of samples or that degrees of freedom. So I think I have a question. I'm totally moving forward, don't care. Here we go. This one, question 2, way at the very bottom of our note packet. Again, this symbol just didn't come through right. What are the values that correspond with 95, 98, and 99, given we only have a sample size of 15? It kind of printed it weird in mine. So let's go to StatCrunch. And I am actually going to open. Okay, so we're in StatCrunch. We're going to go to Stat. And we're going to go to the calculator, and we want the T calculator. Okay, we always want the between, not always, but a lot. When we have that symbol of the little fishy divided by 2, that means true tail. Significant level divided by 2 is really what it's saying. Okay, then we're going to put in our degrees of freedom, and we had only 15 samples, so we would put in 14 for this, because we had 14. And then what was our first level? 95%. So 0.95, compute that, and I got 2.144, whatever. So for the 95%, the critical value is 2.14. Okay, if we keep everything the same, but we try this for 98%, right? Then compute, we get 98%. Still at that same degrees of freedom, we get 2.62. Okay, and 99. So when you're doing these, they're all around 2 or 3. So that kind of helps you see if you did anything wrong. I need 99. And the last one is 2.98. So these numbers aren't like our Z's. We can't just write them down and use them. Unfortunately, we have to go to the calculator, go to the T calculator every single time for your specific question. So that makes the formula a little harder than our formula that we used for 7.1. Okay, so that's our T. We call those our critical values, our T value. Okay. Then let's see. Where were we? We were just talking about, that's where we talked about how to find it. And then I just scrolled down and did it for those 3 problems. So to find our confidence interval, we have to find that error, right? And then we add and subtract it from our mean that we have to be given. So this is just saying you either have to have a population, in order to do this, your population has to be normal, or you have to have more than 30 data. That's all this is saying right here. And I really like this part. Okay, so margin of error, you minus the upper and lower, right? And divide by 2. So highlight that, circle that. That's probably the easiest way to get your margin of error versus the formula. Okay. All right, this formula here has to do with our, this formula here has to do with what if we want to know how many sample sizes I should have. So I'm like, I want to start this project, but I don't know how many sample sizes I should have. Well, how accurate do you want to be? And you put in that information. And this one has that known standard deviation on this. So you will use a Z for this one because it is that known. It's not a T. It's a known standard deviation. So the sample size ones, you can just use the formula, or when you use StatCrunch, it's a little tricky because you have to use the Z-stat, not the T-stat, if you know the standard deviation. Okay. Sometimes they say just estimate it. You're still going to use the Z, but you're going to estimate that mean or that standard deviation using the range rule of thumb, range divided by 4. Okay, a couple questions with that. So if we have let's summary of methods used. Oh, if we have a sample of 450 people score on the last math test, where the mean of the sample is 75%, the standard deviation was 5. If I want to be 99% accurate, what would the margin of error be? Let's do it with the formula. So we're going to say, okay, the margin of error is going to equal, it said the Z, or I mean, excuse me, the T, the margin of error, because we don't know. Okay, back up for 2 seconds. We do not know the standard deviation. So we are in T world. We know the standard deviation of the sample, right? It says the sample. So be careful of that. We do not know the population's standard deviation. So we're in T world. So in order to get that T value at 99, we're going to need to use that calculator. So I'm going to go back to StatCrunch, open this up. We're still in the between, but our degrees of freedom on this problem was big. It was 450 is our number of n, so we'd use 449. And enter that. And then we want to be 99% accurate and compute, and I'll use 2.59. Okay, so we're going to use 2.59. And then from here, we're going to times it by, let's just scroll up. I know I hate when I scroll. And here's our formula right here. So we're going to do the standard deviation of the sample divided by the square root of n. And we just did all that time to find this value. Okay. If you are looking at the example, it might try to make you use like tables and stuff. No, use the calculator that I show you. Don't use the tables. They're time consuming to learn and tedious. So okay, then we're going to times this by the 5, which is the standard deviation, divided by the square root of 450. This is going to give us our margin of error. So we get out my calculator, 2.459 times that by 5 divided by the square root of 450. Oh, hold on, I messed it up on my calculator. Okay, 5 divided by the square root. I did a square instead of a square root, 450, and I get about 0.61 rounded. So then we take our middle value that we found from our sample, which was 75 was our mean, and we add the 0.61 and we subtract the 0.61. That gives us our two values on our confidence interval because we've now added and subtracted our error to say we're confident 99% of the people who take this math test will be between what is 75 minus 1 is going to be 74.39 less than, and now we use the mean symbol, not the P. It's not a proportion. It's about the population's mean. So we use a population mean symbol. And then we have 75.61 here. So we're 95% confident that everybody will be between 74.39 and 75.69, or their average would be. Okay. All right. So that's our margin of error. There's our confidence interval. Now check this out. I can just go over to stat, close that up. We have all these options. We use this Z-stat. You see the Z-stat? If we know the population standard deviation, rare. Common to find the sample size if you want to use StatCrunch. Otherwise, we're in that T-stats world or the proportion. Those are the three things we really like to use. The rest of them we just won't get to this semester. So we have a summary and we have a mean of 75 and we have, a sample standard deviation of 5, and we had a sample size of 450. And then look, it has confidence interval, and the level of the confidence interval can be 99, which is great because that's what we want. And then compute. So we already got this 74.39, which we got, and 75.61. There we go. I wish I could circle it, but I can't. I touch it all the time and you guys can't see my stack. It's not in Notability, right? It's just on the web, so you can't just click it. All right, so you could get your margin of error and add and subtract it, or you could go straight to your upper and lower limit. Well, if I go straight to this confidence interval, can you still get the margin of error? Well, yes. You can take 75.61 minus 74.39 and divide it by 2. Subtract, divide by 2. So you could use StatCrunch and never really use the formulas. To me, way easier. Okay. All right. This one goes through kind of that idea of T and Z. If you know that standard deviation kind of in words for you. Sample size, we already did that part. Okay. Oh, right. So IQ confidence. Okay. Assume, I'm going to do problem 3 here. Assume that we want to estimate the mean IQ for a population of statistics students. How many stat students must be randomly selected for IQ test to be 95% confident, blah, blah, blah. So we are asked on this one, how many must be randomly selected? How many is our sample size? I want to show you this in StatCrunch and with the formula. So the formula is right here. Okay. I'm going to open the formula over here too for myself. I keep forgetting the formulas for some reason. Or we can use StatCrunch as well. So our formula is going to be, where am I going to write this? Let's write it over here. N equals the Z two-tailed times your standard deviation divided by your margin of error squared. Okay, so I have to find all 3 of those. Well, I'm already given the standard deviation. So to find the two-tailed Z at 95, I actually know that it's 1.96, I'm pretty sure, but we can still double check. So we go to StatCrunch and we want to go to stat. It's a Z, so we go to stat. Oops, close that up. And we go to calculator, and it's a normal because normal and Z go together. And then I want the between. Did I click the between? I don't think I did. Between section at 95. 95. Compute, and I got 1.96. So yeah, I would have used the right number there. Maybe I'll leave StatCrunch open. That's fine. Oh no, you guys can't see it as good. Okay. So I got 1.96. So right now I know the 1.96 here. I do know the 15. Now, do I have to spend the time to try to find that standard error or that margin of error? Excuse me, not standard error. I can't actually find it. I don't have a sample. So it says your error in the problem within 3. That is your error within 3. So we're going to divide this by 3. Okay, so I'm going to do that on my calculator. 1.96 times that by 15, divide that by 3. I get 9.8. You square that and I get 96.04. But you have to round that up to 97. Okay, so this is our N equals 97. That's our sample size. And let's do that same thing on StatCrunch. So that's our formula. And in StatCrunch, it will be stat. And then we're going to go to the Z section because Z stat right here, because we know the population standard deviation. They gave it to us. Or you can estimate it with a range rule of thumb or something like that. So we have a one sample and we go to that width sample size because that's what we're looking for, sample size. Okay. And then this one is we want 95, right? Yeah. And our standard deviation was 15. Okay. And our width is always double our error because it's the whole width. So if we're going both directions, 3 points, our width would be 6. Okay, and compute, there's our 97. So again, we went to stat, ZStat to get this width section, sample size. And we doubled the width, the error. Okay, so getting the sample size is the most commonly missed question on the next test. I'm not sure why. I try to cover it. I try to do some warm-ups with it. If you're in my live class, if you're in my online class, I don't have warm-ups for you because I don't see you. So, whatever will help you. You're allowed notes, a page of notes again on your test. So, all right, this number 4. Here's a summary of stats for randomly selected weights of newborn girls. So we had a sample size of 263, so we don't have to find the sample size because we were given it. This should have a bar on the top. It disappeared. It's a mean. X bar mean 35, so that's our sample. And a standard deviation of 8.3. Construct your confidence interval at a 96% level. So I like StatCrunch. Thank you very much. We're going to close. Now, we have a standard deviation on there, but notice it's an S equals 8.3. The S is sample. So we're going to go to stat, and we're going to go to T, because we usually are in T. Z really is sample size, and that's it. Okay, hardly ever. Okay, here we go. Unless you create some kind of a weird one where we end up needing that for your project, but I doubt it. So here we're going to put in, oops, why did I go to width? Stat, just because we were talking about it. Width summary, there we go. I was like, what am I doing? So we're going to put in our mean. Our mean value was the 35.1. And our standard deviation was the 8.3. And we had a total of 263 people, and we want a confidence interval at the level of 96. So take a second to see that. So this is in the T statistic, and we're doing a confidence interval, and I'm going to hit compute, and it gives me that lower and that upper limit for me to write out my confidence interval. When I write this, I have to use the right symbol. So 34.04, we'll just do 2 decimals, less than the fancy mu is less than 36.16. Okay, if I wanted the margin of error, I could subtract those numbers and divide by 2. Are these results very different from the confidence interval of 33 to 35 with only 24 samples? No, they're not too far off. 33, we're off 1 more. So if we did a lot smaller sample, we're off 1 more whole number in both directions. So it's not too far off. I guess it depends on how accurate you want to be, really. That's what that question should say. So look at 5. It listed these that kind of went on 2 things here, but listed below are the amounts of net worth in millions of dollars of the wealthiest celebrities in the country. They're worth 285 million. Oh, they can give me one. Construct a 99% confidence interval. And then we'll just start there. So we can do the confidence interval from data. It's a lot harder with the proportion because you would be putting like accurate, accurate, inaccurate, accurate, accurate, or something with words, or yes, 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 no, 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 or something like that. With the mean, it's a little easier to do. So we could do this, find the mean and standard deviation and use the formula, but I like to make StatCrunch do it. So we're going to put our data in. 285 was the first one, 230, 170, 165, 165 again. Oh, we have mode. 150, 140. I wish I had one of those buttons right now to just bounce my data over. I've been creating those in a lot of my notes. Did not today. So 130. Okay. So I think I have all the data incorrect. There's 10 data. We should be getting close enough. So once you have your data in, now we definitely don't know the mean standard deviation of the population. I'm so sick of saying that, but we have an unknown standard deviation of the population. So we go to stat and we're going to go to T again, that's open already. And we want to do with data. Okay. Then you have to pick your column. So ours was in column 1, right? I don't know. I think it was confidence. And then we're at 99%. So we're there. Compute 218. Uh-oh, close. Wait, did I have? Oh, I had the data in there twice. Okay, well then that one was fine. So let's just do it again with data. It's in both because I've already done this. I just forgot to record in class today, so I'm making another video. It's fine. I needed a new one anyway. So confidence interval 99. Perfecto. So we just put in the data. You pick which column, and then from there. Okay, so we have a confidence interval, we would say from 118.5. I do not know what the line was. 0.5 is less than, it's a mean, so we use our mean symbol, 221.50. Okay, so there's our confidence interval. Let's see what it asks us. Does the data appear to be normally distributed? Well, let's look. So if we want to look at normally distributed, we could use a QQ plot. We could graph a scatter plot. Not a scatter plot, what I mean, a histogram of that data. Does that look like a bell shape? No. We could also, the more accurate one was, oops, I went into the wrong section, graphed QQ plot and of our data. You don't have to change on a QQ plot. You really truly are just put the data in, push compute. Does it form a line? That's a big fat no. It should be a very accurate line. Those dots should be on the red line. So no, does not appear to be normal. Not normal. Okay. And whether we use a QQ or histogram, still not normal. The QQ helps when it's kind of like da 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 da, and then a little bit up, and then maybe a little weird. You're like, I don't know, it kind of looks normal. That's where that QQ plot could really be more helpful. Okay, so do they appear to be normal? No. Okay, that was all that question asked, I guess. All right, I think that's good. We're good. All right, so you can find the standard deviation. Find the standard deviation. Find the confidence interval from StatCrunch. You can also find the margin of error in there. Okay, kind of up to you. Remember the wording after you find this confidence interval, like this one here is, we are confident at the level of 99% that the true population is between 118.5 and 221.5 for their average. That's our wording. Fancy wording. All right, let me know if you have any other questions. Good luck.